Now, from rotational motion, moment of inertia, we are discussing. In the case of moment of inertia, we are going to find now what is the moment of inertia of the thin rod. Yes. Now here, thin rod we are going to take. What is the moment of inertia of the thin rod about a given axis? So how to find that one we are going to discuss now. Okay. Yes. Here, to find moment of inertia of the thin uniform rod about an axis passing through its end and perpendicular to its length here. Yes. So this is the figure here. Yes. This is a thin rod. This is the axis of rotation. About this axis of rotation, we are going to find moment of inertia. This thin rod is not a particle. It's not a point mass. It is a rigid body. So what we have to do, we need to take a small part of the body, okay, which is located at a certain distance from the axis of rotation. So let us see. This is the small part of the rod here. Okay, it has length dx and its distance from the axis of rotation is x here, like this. Okay, assume that it has mass dm. Okay, now to find moment of inertia of this small part about the given axis of rotation, this is the formula I equal to integration of dm into x square. This is the formula to find moment of inertia of rigid body about the given axis. Then here dm, how to find dm? Very easy. So here remember, we are taking the uniform rod here, yes, which means mass per unit length is what? Same, yes. So we take total mass is m, total length is l here. So total mass m, total length is what? L. Like that, if you take the small part here, its mass we are taking as a dm and its length is what? Dx. From here, dm is equal to m by l into dx. Okay, so let us substitute here. Yes. Therefore, I equal to integration of here m by l into dx into x square. Okay. So limits, let us see what are the limits here. Limits are becoming here 0 to l here. Yes. So as a next step here, m by l integration of here x square into dx. So limits as usual 0 to l. So as a next step here, m by l into integration of x square dx is how much here? X cube by 3. Yes, x cube by 3. Limits as usual 0 to l. Okay. Now let us bring 3 outside here. M by 3l into x cube. Limits 0 to l. Okay. And in the case of limits, we know we have to substitute upper limit minus lower limit. So m by l, m by 3l. So upper limit is what? L. Lower limit is what? 0. So therefore here L cube minus 0. As the next step here, m by 3l and here L cube. So that gives here m L square by 3. Yes. This is the moment of inertia of the rod about the axis perpendicular to length and passing through end, like this. So the figure shows clearly the axis of rotation. So this is the moment of inertia of the given rod about that given axis. Okay. Now let us see what is the moment of inertia of the same rod about other axis. See as a next slide, see. Yes. Now here to find moment of inertia of the thin uniform rod about an axis passing through its center of mass, a center of mass and perpendicular to length. Now this time axis of rotation is different here. So this is the figure here. So this is the rod here and axis of rotation is passing through. This is the axis of rotation. This is passing through center of mass. This is the center of mass here. Okay, and perpendicular to length of the rod. Yes. Now we follow same method. Okay, so to find moment of inertia of a rigid body about a given axis, I is equal to integration of dm into x square only here. Okay, now here just like a previous case here, mass per unit length is constant here. M by L is equal to dm by dx. Sorry. So dm by dx. Now here dm is equal to, m by L into dx. So let us substitute here, integration of here, okay, m by L into dx x square. So limits yes. So here just like similarly, see here dx and its distance from the axis of rotation is what? X only here. Okay, and the limits becomes here. Whenever this small part is taken exactly here, so that x becomes 0. When we move away from the axis towards the end here, the x becomes L by 2. Similarly, on the left hand side, so 0 to minus L by 2. So the limits will be minus L by 2 to plus L by 2. Okay, now as the next step here, m by L integration of x square into dx. Limits are as usual here. Okay, therefore here m by L x cube by 3. So L by 2, of course minus L by 2 to plus L by 2. Now if you substitute here upper limit minus lower limit here, m by L, okay, by here 3 is there here, x cube, yes, x cube means here L by 2 whole power 3 minus here minus L by 2 whole cube, means here minus minus becomes plus, and here L by 2 whole power 3. Okay, so if you see as a next step here, m by 3L, and here this becomes here 2 into L cube by 8 here. Okay, now 2 1 jar, 2 4 jar, 4 into 3 12. So here one L gets cancelled. Finally we will get here ml square by 12. Yes, this is the moment of inertia of the thin rod about an axis passing through center of mass and perpendicular to the rod. Yes. So like this we can find moment of inertia of a thin rod about different axes. For about any axis, so please try to remember. So this is the formula here. Okay. Okay. Thank you.